Right. Great. So I think that our last video has cut us because I think the battery was low, and then we are not aware that only the people who are here are actually the one who are benefiting, not the people on live stream. Okay, we're going to go back to calculating the effective interest rate. I hope now it makes sense to you guys, because I think that's where we ended in the previous live stream. So we're going to have like we said, the formula will be 1. This is one of another example. So will be 1 plus effective interest is equal to 1 plus over m. You can call it m or over m, as long as you're utilizing it properly. So we see that we're calculating the effective interest rate if the interest is compounded at 5% per annum compounded quarterly. So this will be 1 plus effective interest, which is equal to 1 plus IM, which is the interest, 0.05. And then remember, it was compounded quarterly, so it is divided by 4, and then M will just be 4, because we say that in a year, how many quarters do we have? We actually have 4 of them, so hence we're dividing by 4 and also multiplied by 4, and then our effective interest will simply be 1 plus 0.05 over 4 to the power of 4 minus 1, and our effective interest will be, and then we can just press in a calculator and see how much we get. We have open bracket 1 plus 0.05 divided by 4, close brackets to the power of 4, and then minus 1. So our answer is simply 0.0509. So if the interest rate, if you're looking for the interest rate, we just multiply this by 100, and then this will give us, let me multiply this by 100 and I get 5.09%. And then per annum. Like I tried to, like I explained to you guys, you say once you say effective interest, you're talking per annum. Good. And then let us see if we can do more of these problems. And I also have given you a different problem that has different wording. And they call it the nominal interest. The interest that is given to you to find the effective interest is normally called the nominal interest. This is the normal interest that is given to you, as far as the number of compound per year has been given to you. For example, it can be compounded monthly, it can be compounded annually. Not annually is effective interest, can be compounded weekly, can be compounded daily. It will depend how they give you. So they will also say you are giving the nominal interest. Sometimes they will say find the nominal interest rate, then you know that if you are doing the effective interest, from learning how the effective interest has come about, you'll be able to move backwards to be able to find your nominal interest. Now let's take a look at this one quickly. We have a nominal interest rate of an investment which is 12.35 per annum compounded monthly. We want to calculate the effective interest rate. So our effective interest rate will simply be 1 effective, which is equal to 1 plus to the power of m. Remember, this will not be given to you in a formula sheet, so you need to always be able to know how we get about this formula, or remember how to rewrite the formula and be able to use it. So the interest rate that is given to us is actually 12.35% per annum compounded monthly. We want to calculate the effective interest, so we're going to have 1 plus effective interest, which is equal to 1 plus, and our effective interest, our nominal interest was actually 0.1235. Then we're going to divide it by 4. No, divided by 12. Good, divided by 12. Why by 12? Because it was compounded monthly. So if you divide by 12, you must also multiply by 12. So your effective interest will actually be 1 plus 0.1235 over 12 to the power of 12. Please, let's before you think it's a square root, to the power of 12, and then you minus 1. Then you can press this in a calculator, and then you get your effective interest. If you have any questions about this, you can still send me a message on WhatsApp. You can also send them on the comment sections. You can still comment and put a timestamp where we actually lost you. I'm gonna keep on checking if the video is still live, because it's just off and I will not be aware if it's off. Alright. Let us now move forward. I hope you can still see it. Let's check you can still verify. Let us now move forward. Sorry to the view. I think we're still better, we're still good. You can see the whole board. Perfect. Good, let's put it straight. Good, I'll try to use bigger handwriting so that you can see. It's very, very important. Let's move to let's now take a look at question of this kind, where we call them the book values, where we'll be using the reduction balance method, because the amount that we had will be bigger than the amount we're going to have currently. So it means that in the future we will have the value of that, for example, of that tablet being reduced to a certain amount depending on the interest rate. So we're going to do problems of that kind. I'm going to use this one as an example. Let's take a look at what Karabo has bought. Karabo has bought a computer for 4,700 rand. The value of the computer depreciates. So we have keywords here. In finance, you need to look for keywords. So the computer depreciates. So it means the value will not be the same in the next coming few years. So it's going to be lesser and lesser. So our, what we call our principal amount will actually be bigger than our accumulated amount. In the, for example, the value of A. And then we have an interest rate of 18% per annum. So we are using the reduction balance method. So we have a straight line method, and then we have the reduction balance method, which is, this one is more exponential, where n is an exponent. So calculate the book value because it depreciates. So I'm going to use this following form. A equals to P, because of depreciation, is going to be a minus, because we have depreciation, or you can see it by looking at the book value. You know that a book value of any object will actually depreciate. And then because we're using a reduction balance method, this also confirms that it's a minus, and the reduction balance method is the one with exponential, we go to an I to the power of n. If it's a straight line, then we will have a is equals to p because it depreciates I to the power of n. But at least now it is not that. This is used for this one. So this one is a straightforward question. So remember, we cannot put the rate as it is as 18%, so we need to divide that by 100. So we'll have accumulated amount, or this will be the principal amount. This is what we start with. So our amount that we accumulated, or the value, or our book value, the amount after a certain number of years, will be 4,700. 1 minus our interest rate is actually 0.18, because we're going to divide this by 100 so that we can get our I. So we must divide this by 100. So this will just simply be 0.18. You can also verify it, and then the number of years that we need to see how much will that computer cost after those years. How many years is 4? It's actually 4 years. So we want to find out how much will this computer be worth after 4 years. So we put n as the number of years, which is just 4, and then a will simply paste this in the calculator. I think it's a straightforward one. Apologies. It will simply be 4,700. You open the bracket, then we have 1 minus 0.18, and then you close the bracket to the power of 4, and our answer is actually 21,024, or it's 2,000 actually, 2,124, right? And 97 cents. So we cannot have more than 2 digits when it comes to money, because it will not make sense in real time. Hope this makes sense. Every time look for the keyword reduction balance method, we use the exponential one. If they say a straight line, you know that, or simple reduction, you know that you're going to use the one which is linear, and this will always give us a straight line, and this will give us an exponential curve. Good. And then let us now move forward. If you still don't, please go back, please slow down the video, please pause and make sense of what we are doing here. And then now let's move into another example that almost looks like this one, so that we can consolidate it. Now, when we're reading through this, it says a company bought a machinery costing 80,000. So using a reduction balance method, so already we know that we are going to use A equals to P 1 minus I to the power of n because of this keyword. And then the methods, using the reduction balance method, the machinery had a book value, and also this also confirms that the value needs to be actually have been reduced. It needs to depreciate. All the book values, they depreciate. They go down, so they depreciate. So this time we are calculating the interest rate, which is good, because now at least we can be exposed to finding the rate. So let's take a look. The formula says we have A equals to P 1 minus I to the power of n. So out of these two, from these two amounts, a company bought a machinery costing 8,000. This is the principal amount. That's what they started with, which was 80,000, and then they ended up with the value of the of that machinery being 20,000. So we have 20,000 this side, and after how many years? 5 years. They started with 80,000 worth of machinery, and they end up with 20,000 worth of machinery, and then 1 minus the interest rate, we don't know it, and then n is just 5 years. So what we can do is to divide both sides by 80,000, divide both sides by 80,000, and then if you simplify this side, I think it's going to give us 1/4, and this will just give us 1 minus I to the power of 5. So this will divide this, and then on the left hand side is 1/4. So if we move forward, we can just root of 5 for both sides. So I'm going to be left, I can just take this one to the other side to say, okay, I have a root of 5. Let me just write the proper root of 5. Okay, and then on the other side will just be 1 minus I, and then we can simplify by taking I to the other side. So I'm going to say minus 1 equals to negative I, and then this can simply be I multiply everybody by negative, whichever is negative will become positive. So this was negative, it will now be positive. This was negative, it will now be positive. This was positive, it will now become negative. And I press this in the calculator, and I find my I to actually be 1 minus, pressing the calculator, shift, and then as I see it, and then my I is 0.2421. So if I want to find the interest rate, I'm just going to multiply this. I'm just going to multiply this by 100%. And it will give me 24.21% per annum. Yeah. So sometimes can be given to you in different formats. As long as you can pick up the keywords, you'll be able to do well in terms of in finance. It's an easy topic to easily totalize it, provided you can pick up what is given to you and what is required from you. So these are the book values example. You can also go back and practice more of these problems. Look for these problems in the grade 11 question papers. It is very rare you finding them in grade 12 paper, but they are also there when the examiner try to test the grade 11 concept. This was learned intensely in grade 10 and 11, so please do pay attention to it. And then we will now move to next example, and then the next example will now be dealing with timeline. So I need you guys to freshen up your brain. I'm just gonna give you a few seconds, and then if you still have questions, please don't hesitate to call to send me a WhatsApp, or you can on the video, once the video has been shared with you, those who are not live, you can just timestamp it and then ask the question. I will check and then be able to make sure that you are clear about what we're doing here. So these are the first concept. In the first video that was cut short, we're dealing with effective interest. Make sure you know how to write the formula of the effective interest. We dealt with the book values, with its depreciation, and then we're going to now deal with your timelines and dealing with investment and so forth. So please do take this into cognizance to say you're only going to be tested with as far as grade 11 concepts are concerned. So one of the interesting concepts in grade 11 as far as finance is concerned is the timelines. So please pay attention to it, and it actually has a lot of marks. All right. If you need the slides, you also need to let me know. I'll take them before we conclude our lesson today. All right. Good. Now, with timelines, your timeline is drawn. There's no universal timeline. Your timeline is drawn with what is given to you. Let's look at the let's use this as an example. I think I have a few examples that will actually try to explain as many scenarios as possible. But once you understand how the scenarios actually can be represented on a timeline, it will be easier for you to actually make your own timeline. Okay. That's going to be the initial deposit of 20,000. So let's take the conditions and whatever is happening here, let's write it down. Here I am, initially, which is today. Ntlanta made an initial deposit of 20,000. I'm going to put all the deposits on top. So I have 20,000 that is placed by Ntlanta, and then into an investment account that paid an interest rate of 7.2 per annum compounded quarterly. So the interest rate here, I'm going to write it. The interest rate was actually 7.2 per annum compounded what? But look at the statement. After 2 years, the interest rate changed. So it means from here, after 2 years, the interest will change. And the new interest rate will now be 7.8% per annum compounded monthly. So I'm writing it down. The interest rate, it is now 7.8% per annum compounded, let me just say month, so that you can see it. 4 years after this initial deposit, 4 years after his initial deposit, Ntlanta withdrew 2,500. So after 4 years, you see, it is very key because they say 4 years after the initial deposit. So 4 years from here, not 4 years from after the interest rate has changed. So 4 years, Ntlanta now takes out an amount of 2,500. Let me put it down. 2,500 has been withdrawn. Whatever is on top is been deposited. Whatever is at the bottom has actually been removed. And then from his investment, so it was removed from his investment. I don't even know what the question is, but from the scenario, I can already have an idea what is actually happening. There was a deposit, there was an interest rate after 2 years that changed, and after that it means that for the duration of the investment, we still had the same interest rate. So these are our two interest rates. And then we had a withdrawal after 4 years. So Now let's go to the question. We say calculate how much Atlanta had in this investment after 2 years. So it means we don't want anything that happened after 2 years. It means that we just want to know how much did Atlanta have when we get here. It reaches after 2 years. The only minor direct deposit that was actually 20,000. So we are going to have, what's the investment? We're going to have A is equals to P plus 1 to the power of N, because everything has been compounded quarterly, compounded monthly. So most of the investment, even when you go to the banks, most of the investment, they are compounded. So we're going to use our formula as the financial growth, compounded growth. So after 2 years, this is a straightforward question. We're just going to substitute. Let's substitute and say, okay, that after 2 years, your accumulated amount after 2 years will simply be P. Our principal amount was just 20,000. And then 1 plus our interest rate, which is 0.072, and because it was compounded quarterly, we will divide the interest by 4, because in a year, how many quarters do we have in a year? We have 4 quarters in a year. So this interest rate is per annum, but it's compounded quarterly. So it means it must be divided into two times. It will compound each and every quarter. So it's gonna compound 4 times, and then we have the number of years, which will be the number of years, and multiply by the same 4, because now remember it will be compounded 4 times in 1 year. So it means how many times will it compound in 2 years will be 8 times. So how you can easily find that is take the number of years, because we divided by 4, also multiply by 4. Ask yourself how many quarters are there in a year. If they say months, you divide by 12, because we have 12 months in 1 year. If you see all of this interest, they start with per annum but compounded quarterly. So you must ask yourself how many quarters are there in per annum, how many months are there in per annum. Then you divide. If it's monthly, you divide it by 12, and if it's quarterly, you divide by 4. The reason why we divided by 4 only is because the interest rate here was effective for the first two years, and after that we don't want to know anything about that yet. We just say calculate how much Atlanta had in this investment account 2 years after the initial deposit was made. So we are just focusing until here. Then you press this in the calculator. I think it's straightforward. Then you also press it on mine, so that you can also get used to pressing the calculator. And the most important thing is that when you practice finance, you must practice with your own calculator, get used to it. You cannot come to the exam and then try to do finance for the first time with somebody else's calculator. It's going to show you flames. You need to get used to pressing the calculator, so that you can be quick. My answer was actually 23,068 rand. 12 cents. Good. Straightforward, beautiful answer, a simple timeline question. But now let's make it interesting. Please remember that timeline. We're going to redraw it again as we go to the next question. So let us save this. And then same question. I'm going to redraw that timeline. Just gonna make it a bit bigger. This is T2, T initial, and then we had also T4, where we had a withdrawal, a deposit, two interest rates. The other one was 7.2 per annum compounded quarterly, and then the other one was 7.8 compounded monthly. And then, yeah, so now the question continues to say, how much will the investment be worth 7 years after the initial pay? So it means that they are saying they are looking it for after 7 years. So what I want you guys to understand what is happening here is that whatever happened here, the interest changed after 2 years, we still have the money in the account. We are going to take this 20,000 and run it until the end and see how much it's going to give us. Then subtract the 2.5 together with the interest it was supposed to have gained. So anything that you withdraw, you subtract it together with the interest that is going to withdraw. This is what I mean. The 20,000 that was initially placed, it will, our amount after 7 years will be the 20,000 coming from this formula. Because this is an investment. So it's going to be compoundable. So this is what we got, the 23,000. So I don't want to write it again and compound it. So I'm going to say 20,000, I'm starting from here. The interest rate was 0.072. This was compounded quarterly. So I'm going to divide this by 4. But this has run for 2 years. Remember, this was just 2 years. The interest rate was for 2 years. So this is 2 years. The number of years is 2 years. So I'm going to say 2 years. But remember, I'm compounding quarterly. So I multiply the number of years by 4. But the money is still within the account. The money is not taken out, or there's no new money. So this money will continue to gain a different interest now, using the different interest rate. So I'm going to have, this is now my new P. It is now my new P. Or you can find the value of this and then continue again, rewriting the formula again. But I want us to do it in just one line. So this is my new P. I'm just going to add this part because this becomes my P. This is my P2. So the whole thing becomes the P2, which is the same amount that we got last time when we were doing the problem at 7.3.1. So the P continues now with a new interest of 0.078, but this time it is compounded monthly, so we divide it by 12. And for how many years was this interest effective? From second year until 7 years. So it's going to be, number of years will be 5. But because number of years will be 5, but because it was compounded monthly, we multiplied by 12. This, we have taken the 20,000 and ran it until the end. And then we are going to now remove, when I use rate, we are going to remove the withdrawal. The withdrawal was 2,500. The reason why I'm removing the withdrawal is that not only did we take the 2,500, but that 2,500 would have gained us certain interest, which we already calculated for the 20,000. So we take the 2,500 together with the interest that 2.5 would have gained if it was left in the account, because we have already calculated how much will this 10,000 give us after 7 years. So we're going to take out the 2,500 together with the interest it has gained. So we're going to take 1 plus, please don't use a minus this side because we've already used a minus on the other side. Sorry. So the interest is the same interest, but now remember this withdrawal was taken after 4 years. So it will just be the interest of 3 years. So I'm going to have 0,078, then divide by, because it is still the interest rate that is given by that bank on that year. So it is still compounded monthly, we divide by 12. But how many years does this withdrawal take place until the end? It was just 7 minus 4, which is just 3 years. So we have lost interest of 2.5. That would have made us an interest for 3 years. Then multiply by number of years is 3. But remember, it's compounded monthly. So we also multiply by 12. And then you press this in a calculator as it is. Apologies, and it will give us the answer. Eh? Let me see. It's 20,000. 1 plus 0,072, 0,072, divide by 4, close bracket to the power of 8, and then open bracket 1 plus 0,078 divided by 12, close bracket, and then this will be to the power of 5 times 12, and then minus 2,500, open bracket 1 plus 0,078 divided by 12, close bracket to the power of 3 times 12. So our amount, total amount, please also verify it's just 30,871.48 cents. Yes, so there's few questions that one can ask to say, because we have found the value here, why don't we take the value and then we can still do that because we already have an amount of this part. This is what you did in the previous question. And then you put in the interest only and then subtract the withdrawal. You can do them separate, but I like to do them in one line so in case the examiner would just ask you from without 7.3.1, we have 7.3.2 and say, how much would the investment be worth after 7 years, after the initial deposit was made? So that you don't have a lot of steps. You can just do it in one line. As soon as the amount is only one deposit, I want you to, whatever amount that you are depositing, take it until the end. Whatever amount that you add again, if you add up another amount this side, take it until the end of the investment. And then, if you have any withdrawal, you take the withdrawal, put in the minus, and take it to the end of the investment. You will never get them. As long as only the interest changes, the brackets that has the interest are the ones that we are adding up to the same 20,000. But if you have a different deposit, then you could just put it in. But I think we'll have a problem that will actually address if you have more than one deposit. I hope that everybody is following what this one. Yeah, we're just left with an hour. And then all right. Let's take a look at a different problem. Look at this one. This one goes straight to say, calculate the value of the investment at the end of the year. It's not separated. So I want us to build a timeline as far as this is concerned. And we are going to say, from the information that is given to us, let me just draw a bigger timeline so that we can see it. So we have Sipho invested 80,000 for 6 years. So I think our timeline will take 6 years. So the investment and interest at 12% per annum. So initially, Sipho has actually invested 80,000 into the account. The investment and an interest of 12% per annum compounded monthly for the first 2 years. So for the first 2 years, the interest rate that it gained, let me just use, this is 2 years. Use a different color so we can see the interest. The interest rate this side. For the first 2 years, the interest rate was actually 12% per annum. But it was compounded monthly. I'm just thinking what I see from the information given and then put it into my timeline. Remember, this is my initial, where I have started, T0. Okay, so the investment and interest rate of 12% per annum compounded monthly for the first 2 years. This has been accounted for. Number of years is 2 years. Thereafter, the interest rate changed to 10.8% per annum compounded semi-annually for the rest of the period. So the interest rate here for the rest of the period remained at 10.8% per annum, but it was compounded semi-annually. And then the question says, calculate the value of the investment at the end of 6 years. So this is simple interest exchange. There is no deposit in this regard. So this is very, very simple. So it means our A will just be P1 plus I to the power of N, but with having different interest rates. So we have two different interest rates with the same principal amount. So our A after 6 years will simply be your 30,000 1 plus the interest rate is actually 0.12 because it's 12%, and then remember it was compounded monthly, so we must divide it by 12. For how many years? This has taken number of years is actually 2. So the number of years is 2, but remember this is compounded monthly, so you must also multiply by 12. As soon as you divide by 12, remember the number of years must also be multiplied by 12. Hence, I want your timelines to always be in number of years. And then because the money is still in the account, it has not been withdrawn, there's no another amount that has actually been deposited. It's the same amount. You can open the new bracket and then change the interest. The interest now has changed, and it is just 1 plus. Our interest is now 0.108 divided by semi-annually will be how many semi-annuals are there in a year? There's just 2 of them. These are the half years. And then how long will this last? The interest rate last. From here it will just give us 4 years. So number of years is 4 years. Remember, we also have to multiply by 2. And then you can press it in the calculator and see how much you get. And let us see. For interest sake, just to encourage you to always press your calculator. You cannot practice financial mathematics without a calculator and expect to answer with the calculator at the exam. You are going to waste your own time. So it's better you get used to pressing your calculator. See how much I'm struggling with this calculator because it's not mine. So I'm trying to figure it out at the same time and try to get the answer correct. So you don't need that pressure, because you are a student. Make sure that you use your own calculator. You don't have a calculator, you must tell your parents how important it is for you to have that calculator. So you can practice with it, get used to it. And I'm telling you, sometimes we don't finish because we don't know. We finish because we are wasting time trying to figure out how to use the resources that we have because we don't practice with them. That's why I get very scared when somebody say, "Sir, can you borrow me a calculator while you are investing?" Okay, our answer is 58,017 rand with 51 cents. So their investment actually made money, unlike the other one, because there was no withdrawal. So please check such problems, and then hopefully we'll get more scenarios. But I'll also give you a different scenario where we have multiple deposit, and we also have a withdrawal, and we also have a change of interest. Yeah, the good thing about it is you can always pause the video. Good. Let us now take a look at the next problem. This one is for Mary. Right. So what happens is Mary deposits 25,000 into a savings account with an interest rate of 18% per annum, compounded monthly. So this is the initial one. I'm just going to do the timeline, and as soon as you can get the timeline, then you get a feeling of what the problem requires from you. Good. Even though my timeline is not straight, but the main thing is to understand what's actually happening. So we have an initial deposit of 25,000. Into a savings account with an interest rate of 18% per annum, compounded monthly. So we have an interest rate. Let me just put in the interest rate of 18% per annum, compounded monthly. I'm just taking the information that I get from the statement. Mary withdraws 8,000 from the account 2 years after the initial deposit. So after 2 years, Mary decides to withdraw the money. So he decides to withdraw an amount of 8,000. So we can just say 8,000 has been withdrawn. It's at the bottom. I'm putting this negative so that you can always remember every withdrawal must be subtracted from the account. And she deposits another 400k, 4,000, not 400, 4,000. But when does she deposit it? She deposits another 4,000 into his account. 3.5 years after the initial deposit. So it means 3.5 years. So I'm going to do this. 3 years, initial deposit is this one. And 4 years, that means I'm going to say in between it will be 3.5, which is 7. No. Let me write it as 3.5, it's fine. Three and a half years. What amount will Mary have 5 years after making the initial deposit into the account? So our timeline will end at 5 years. Please bear in mind, the interest rate has not changed. The interest rate has remained the same across all the years. We have the same interest rate. So this is what's gonna happen now when we have the same interest rate. It means every time we'll be using the same interest rate for any deposit or any withdrawal. Remember, after 3.5 years, Mary has actually paid another amount of 4,000 rand into their account. So when you have a problem like this, and we have A equals to P1 plus I to the power of N as our mother equation or formula we're going to use. So let's start here. After 5 years, your initial amount that you're going to put was 25,000. Take this 25,000, push it to the end. Everybody claim whatever is coming into the account, push it to the end. Whatever is withdrawn, subtract it and push it to the end. So we have 25,000. It took how long? Because the interest doesn't change. So there's no any stoppage. So we're going to have 1 plus 0.18 because we divide this by 100. And then because it's compounded monthly, we divide it by 12. How long will this last? 25,000, we move it until we get to the end. Actually, the end is here, after 5 years. Good. So we move it until here. Good. So it's 5 years, but remember it was compounded monthly, so we multiply by 12. No interest change, so no effect. Now we have another deposit. So once you have another deposit, you add. Withdrawal, you subtract. If it's the same amount, just different interest, keep opening the interest bracket. Keep opening the interest bracket. And then you will reduce the number of mistakes that you're going to do. Now, we have an initial amount of 4,000 that was placed. Remember, this was placed 3.5 years after the initial investment. So it's going to be 1 plus. And then the interest rate is still the same because there's no any other interest rate. So we're going to use the same interest rate as the one we used for the 25,000. And then divide by 12. And then how many years? How many years will this 4,000 spend on this account? Remember, this is 5 years, right? So 3.5 years. So what we're saying is that now 5 minus 3.5 years will just give us 1.5 years. So we have 1.5 years. So we can write it as 1.5. This is a number of years, but we have to multiply it by 12. Every year we multiply it by 12. And then don't forget the withdrawal. We're going to use blue for the withdrawal. In the same line, we can take on the withdrawal and say 8,000, which was withdrawn. But it was withdrawn where? Immediately 2 years after the initial investment. So this, we also take it to the end. And when we take it to the end, how many years did he spend until it got to the end? Because this was the 8,000 was supposed to have gained that interest. But because the 25,000 has been accounted for with until the end, we take out what the 8,000 would have built the interest from, because we took out after 2 years. So from to 5 years we'll have a simple 3 years. 2 years, then we'll have 3 years, so we have 1. Same interest, 1.18, because that's the interest of that bank for that month, for that duration of the investment. So this took until the end, it took how much? It took almost 3 years. So it's 3 years, not almost, it's actually 3 years. Don't forget, because it's compounded monthly, and then you multiply by 12. You put it as it is. on your calculator and see how much you get. So let us see. I'm gonna press the calculator with you. Let's start with 25,000. I don't know if you can see this. 25,000. I put it the way I see it. Open bracket, I see a bracket, then 1 plus 0.18, and then divide by 12, then to the power of, then I have 5 times 12, and then plus 4,000, open bracket 1 plus 0.18 divided by 12, close bracket. Remember, we had 1.5 times 12 at the top. Don't forget the withdrawal, which is this minus, and then 8,000, open bracket 1 plus over 0.18 divided by 12, and close bracket to the power of 3 multiplied by, what's the 12? Yes. I place it as it is. It will reduce the number of decimals that you lose along the way. So your answer will simply be 52,636.74. This becomes your final answer. Good. Just check it out. As long as you have a deposit, take the deposit to the end. The number of years that are left to the end. Withdrawal, the number of years that are left to the left, because this has actually counted the whole amount you were supposed to gain if there was no any addition or any subtraction. If you still have any questions, please do let me know, and I'm willing to assist. Now we also have extended examples. Let's take a look at these extended examples, because I want you guys to get a feeling of the timelines. Even though it's grade 11 revision, I want us to actually have a feeling of it. Let's take a look at what is happening. It's 2 marks. Melissa has just bought her first car, so she paid 145,000 for it, and the car will depreciate on a straight line method. The reason why I put this is that so that you can be able to see that not all the problems are reduction. Not all the book values are reduction. We can also use the straight line method. We can always also use the straight line method at the rate of 7% per annum. Calculate the Melissa's car after 5 years, but because it's this, remember looking for a value. So the car's value, so this is the book value. So it will be reduced. So it means A will be equal to P 1 minus IN. Why? Because it's on a straight line method. So the initial amount was 145. So the accumulated amount will be 145,000. Open bracket 1 minus the interest rate was actually 0.17, and then multiplied by the number of years is just 5 years. Then you can press this in a calculator and see how much you got. Let's go. We have 145,000. Open bracket 1 minus 0.17. 0.17 times 5, close bracket, voila! And our answer will just be 21,750. After 5 years. So if you buy a car for 145 and the depreciation is 7% per annum, after 5 years it will be what? Was just verify that if it's on a straight line reduction method. Good. This was straightforward. Just wanted to also expose you to the straight line, because we're talking about book value. That's the reason why we get this smile. So just for your reminder, just you can also make your notes to say in terms of book value, it can either be a reduction balance method or it can be a straight line method. So A will be P1 minus I to the power of n, and this one will be A will be equals to P1 minus I n. So it means that we also have compound growth. It will simply be almost the same formula but with a plus. It is compounded. These are for investments, savings, and then we have decays, straight line decays, and then we also have growth. Yeah, this can also be used for investment, but not in real life. Not in real life. All right. We shall move now. And then the next one, extended examples. We have the investment earns an interest rate of 8% per annum compounded quarterly. At what rate is interest earned each quarter of the year? An investment earns interest at 8% per annum compounded quarterly. At what rate is interest earned each quarter of the year? So it means that these are the problems where we now have to change one interest to the other. So we are given here that an investment has an interest rate of 8% per annum compounded quarterly. We want to know how much will be the interest earned each quarter. So it means at what rate is the interest earned each quarter? Each investment, the interest rate is 8% compounded quarterly, and then it means that what we're going to say, I will simply be 0.0. Remember, the quarter we must divide it by 4 because we have 4 quarters. Going to be 0.08. What rate? So the rate in actual sense will just be 2%. Or we can take the 8% and divide it by 4 because each year we have 4 quarters. Okay? 4.2.1 was forward answer. Calculate the effective annual interest rate on this investment. And we said for effective interest rate 1 plus I effective is equal to 1 plus I m over m to the power of m. So we have 1 plus So we had 0.08 because this divided by 100, this is the rate divided by 100 will give us 0.08. And then because it was compounded quarterly, we'll divide by 4 and then raise it to the power of 4. And then our effective interest will simply be 1 plus 0.08 over 4 to the power of 4 minus 1. And then you can press this in your calculator and see how much it gives you. We have done this just to make sure that we cool down. We are about to wrap it up. So let us also save this one. All right, and then another one. We have 14,000 is invested in an account. The account has an interest rate of 9% per annum compounded semi-annually for the first 18 months. Thereafter, 17% per annum compounded monthly. How much will be in the account after the initial deposit? Let us look at the timeline. The timeline is very important. Once you get the timeline right, and then life will become very good. So this is T initial. They put in 14,000 into the account. And then the interest ends at the rate of 9% per annum compounded semi-annually for the first 18 months. So 18 months, so if you take 18 months, remember 12 months will give us a year. T1 and then T2, 18 months, it will be a year, and 6 months, a year and a half. So there we are, a year and a half. So that's your 18 months. T1, this is 18 months. Then we have an interest rate. The account has an interest rate of 9% per annum compounded semi-annually for the first 18 months. So from here to here, we have an interest rate of 9% compounded semi-annual. I call it SA. Yeah? It's not South Africa, it's semi-annual. And thereafter, 7.5% compounded monthly. Thereafter, the interest rate, I don't know where we are going to end here, 7.5% annum compounded monthly. Let me just write month so I can remember. This is from here. How much will there be in the investment after 5 years? So it means our investment will end after 5 years. T5. So I'm gonna take the 14,000, push it to the end. So this is me pushing the 14,000 to the end. There was no deposit. I had 14,000. And then the interest rate would actually be 0.09, and then this compounded semi-annual. How many semi-annuals are there in a year? Just 2. And then for how many years was this interest effective? For 1.5 years. So I have 18 months, which is 1.5 years. 1.5, I'm just going to do 1.5 to make my life easy. 1.5, and then multiply by, I'm going to multiply it by 2. And then, because this is the 2 that I got here, because it's semi-annually, the same amount is there, so the interest has changed. So I'm going to open another bracket for the new interest. which is 0,075, and then divide by it compounded monthly. How long did this take place? We have 1.5 years, and then minus 5, which is 3.5. 3.5 years with the same interest, with this new interest, and then because it's compounded monthly, we're just going to multiply by 12. So we have taken the 14,000 to the end. What else is there? Nothing else is there. Then you press this in the calculator, and then you get your solution. Let's see if we can get a different scenario than the rest. And if it's the same scenario, then you'll have to this one is just for conceptual understanding. Your compound interest, you'll see it with a curve. This is a compound interest. So what is the value of, that's right, the graph below represents the growth of two investments, one belonging to Dumisani and one belonging to Austin. Both investment earns an interest annually only. So we're going to find out the method on how to solve this problem. So from initial deposit of both investment is actually 15,000 because it says 15,000 of rent. So we have 15,000 as the initial deposit, and then what I will just tell you that the one that makes a curve, it's a compound interest, and the other one is the straight line method, which is here. As you can see, it's a straight line. So, and then we go to the second question. We have the second question that says, this is my interest. So when you look at this line, you use that point because as far as the is concerned, we have both the x and the y, which is a and p. So for Dumisani, the fact that it's a straight line method and it's growing, so we're going to have a equals to P 1 plus IN. So we're looking for the interest rate of Dumisani. Does Dumisani investment earn a simple or compound interest? It will earn a simple interest because it is a straight line. Né? And then initially, the number of years is 31. Remember, initially the principal amount was 15,000. When we get here, this will be the number of years because this is your x and this one will be 31,000. So it means that your accumulated amount will be 31,000. Your principal amount was actually 15,000. That's what you started with. And then you have 1 plus the interest rate that we don't know. We're looking for it. And then the number of years is just 6 years because this is time in years. So we have 6 years this side, and then we can solve, and then by dividing both sides by 15,000, and then you can press this in the calculator. I think it's 31 divided by 5 divided by 15. It's still 31 divided by 15, and on the other side I only have 1 plus 6i, and then I'll subtract the 1 on the other side, so I'm going to say minus 1. So this will be 16 divided by 15. I just subtracted the 1 to the other side. It's equals to 6i, and then I divide by 6, and then my I will give me 0.178. So my interest rate in actual sense will actually be multiplied by 100, and then this one will give me 17.8, which is my interest rate for Dumisani. And then we can conclude to say, hence, let me just close that. We can conclude to say, hence calculate, hence or otherwise calculate the interest rate of Austin investment and give your answer to one correct decimal place. So this is where our point of departure will be, because already we have the rate of the design. Then we can come here and equate the y value, which the y values, which is the w. So that's all we have for today. You can engage with this one, equate the two equation, and then when next I meet you, I hope that when it comes to finances that you're going to write in the examination, you'll be able to ace it. For you to be able to master this, you need to practice it. Practice it, revise, practice it, revise, practice it. And the other thing is that tomorrow we'll be doing a different topic, so it is in your best interest to actually find time to go through the videos again. I'm gonna record it. I've recorded it already. Those who've seen it live, and you have actually benefited from it. There's also a few of the people that also came to take the lesson. And then, yeah, thank you very much. It is now 5:30. Let's see each other again tomorrow. I had to record this lesson again because the phone switched off and it seems as if the only people who are benefiting with this one. So they benefited twice, and then just to make sure that you still have it on record. Good night, everybody. All the best. We have done 2 topics today. Tomorrow we'll try to do also 2 topics, and then making sure that on Thursday we do functions, and then there will only be 1 topic that is your responsibility. It will be number pattern. Yeah? Thank you and good night.